to part 3 of D-Lab's repurposing video series. This is the one you've been waiting for, guys. It's time to wire it up and test it. Keep your fingers crossed. Here we go. Alright, it's time to get this amplifier built. You know where we left off. Got the chassis laid out, tube sockets all assigned to their new function, output transformers installed. Got our pilot light, and our input jack, and the master. Over here, I have arranged the parts that we're going to install underneath. So here are my tone caps, sorted resistors, maybe our biased resistor, we'll see after I install it, screen resistor, and this cap here goes on the 6L6 pin 8. Got a couple coaxes here. This black one is RG174. That is going to go from the input jack down through a rubber grommet and hooked to the 12AX7. This white dual shielded cable will be for the master Von control. So in the last video I configured the power supply. Okay, so that is pretty much complete and wired. This orange runner that you see up here, that's the 250 volt lead that will feed the 100K resistors that hit the 12AX7 tube. Here are our windings for the output transformer. The color code, red is our B+, blue is the 7K lead, and brown is the 5K. We are going to use the 5K for the 6L6. And then that leaves these 4 wires. The black is our common, green is 4 ohm, yellow 8 ohm, and orange 16 ohm, which will go to the output jacks. And that's where we're going to start. I'm going to finish this area and we're going to move our way up. So to make this build process even easier for you guys, I've developed a layout diagram, kind of like Fender used to do. Now here it is, I'll post it, and it's not exactly perfect. I threw this together quickly, but it gives you an idea of how we're going to lay out the components and solder them to those 2 terminal boards. Pretty much everything else from that point is straight wiring to the controls. So it's a very simple layout. No circuit boards. Here we go. Alright, we'll start with the output transformer to make things easier. So I took a pencil and put 4, 8, and 16 so I get my colors correct. The blue will not be used, so that has been heat shrinked. That'll be tucked out of the way. The brown will go to pin 3, and the red is going to go to the power supply. Alright, so here we are. Finish up these speaker input jacks. I've already pre-tinned the wires, made little hooks so they go right in. The black common is going to go on the ground ring of the first jack, and that's also connected to chassis. You can also see by the design I'm not using negative feedback. I normally don't, because I feel as though the feedback actually affects the tone of the amp, and if you don't use it, you don't have to worry about phasing on the output transformer. So I got the speaker wiring complete. That blue wire I'm just tucking on my way at this time. Here's my B+ going over to the power supply rail. Brown wire is going to pin 3. Now we're going to get that screen resistor installed. Okay. So that, if you look at the diagram, we're going to use this terminal on the 5Y3 as a landing point. And then I'll swing the other lead up to pin 4 of the output tube. So I'm kind of a firm believer in using the terminals on tube sockets for routing signals. A lot easier than always having to land terminal boards. Just bring that guy around there. Get him on pin 4. I always try to make a nice little loop to get a mechanical bond on my connections. I don't believe in just pushing the wires through the terminals and soldering them. Alright, first component is installed. While I have access to this little ground terminal on the 5Y3 tube base, I'm going to get the cathode cap installed for the 6L6. Because as we keep going, things are going to get buried. So get in there while you can. Yep, so I wasn't paying attention there, was I? I put that in pin 1. That wouldn't have done much good, would it? Easy to do. Anyway, now we got that cap. And pin 8, where it belongs. Yeah, I make mistakes, but normally I catch them before I blow something up. So quick tip for you. You see that I'm doing my tube socket pin wiring with the amp sitting vertically. The reason for that is when you solder and that solder is pulling towards the heat, the chances of that solder rolling into the cavities of the pin sockets is minimum. Okay? If you laid it with this guy flat on your bench soldering down, the solder can roll down into those pins and damage your tube socket. And at this point, I'm going to install the little cathode resistors on the 12AX7. Then we'll install the 100K resistors to the plates. Then we'll put in our tone caps and wire the controls. Once again, mechanical connections. Alright, so there's the cathode resistors and caps in place. Now you can see I'm soldering these leads direct to the tube sockets, okay? Rather than using two sets of terminal strips and then running wires to the tubes. Making connections direct reduce the noise and saves you the cost of another terminal strip. So for pin 3's cathode resistor and cap connections, I'm using one of the ground lugs on this old cinch socket. That's the beauty of these older type sockets, is they had those little ground rings, right? If you didn't have that, you could either land another ground lug or perhaps find another ground on another tube socket in the area. Well, now we get our 100K resistors installed to the plates of the 12AX7, and that goes to pins 1 and 6. Alright, they're in place. I'm just going to put a little bit of solder on here just to hold them because I have more connections to those same pins, right? We got the tone circuits that are going to come up this way, and then off of pin 6 we're going to take off to this terminal board, and that goes to the master volume control. So here is the 0.022 microfarad cap, which is going to go up to the master volume control. So this is going to go to master pin 2. If you look at the diagram, you'll see that master pin 3 comes back through that coax cable, so there's going to be a runner from here going to the 6L6 pin 5 grid input. So here's the signal input wire going to the 6L6. That's going to go up here to our master control terminal board. I elected to use white for signal, since our coax going to that is also white. So we're wrapped up on this side of the 12AX7. Now we need to add the tone caps off of pin 1 of the 12AX7. Now we got a treble cap. This is a 250 puff. Then there's going to be a 100K resistor, and then we're going to land the other tone caps, and this is right off of the Fender Princeton schematic. It's to print, okay? Well, there's the 250 puff cap. And the other 100K resistor, we all join at pin 1. Just going to throw a little solder on these guys, keep them in place. Get those other tone caps in. So textbook Fender tone circuit, okay. You got the 100K resistor feeding a 0.1 microfarad cap and also feeding a 0.047 cap, and then you've got this 6.8K resistor that goes up to the base pot, which kind of sets your mid-range level. So the next step is run the wires up to the controls. Getting close. Alright, so normally I would orient all these pots in the same direction for ease of wiring, but in this case there's already these index holes for the original knobs, and since this is repurposing, I reused them. Let's get the wiring going. Alright, moving along on the wiring of the pots. This is the ground runner for the volume control. If you ever wonder what terminal is the ground, as you turn the pot, you'll see the wiper arm right down there hit this terminal. You can look inside that little window and see it. So that's the low side of the pot. The high side of volume goes to the middle of treble. The high side of treble is going to go to the 250 puff cap. Control wiring is complete. Now I need to move to the top side, wire up the input jack and the master volume. You might be saying, hey, why'd you start out with a white wire, go to green and then purple? It's because of some scraps I had around. So I'm repurposing my scrap wire. Well, here's my 2-conductor shielded cable for the master volume control. This is my ground. I'm going to use the white with blue as signal in and plain white as signal out. So we need to land those on this little terminal strip. Then I'll hook the other side up to the master pot on top. Alright, we're connected down here. Let's get him flipped around. Swing this coax to the bottom of the master pot. Alright, the master pot is wired. This is ground, signal in, signal out, which you would think is opposite, but I'm relying on this pot to load the grid of the 6L6. If 1 meg is the wrong value, I may have to change that to a 500K, but I prefer to use this pot because it's a really nice high quality Honeywell pot, kind of military grade, like the unit that we are repurposing. Alright, next we need to wire up the input jack. We're going to do that Fender style with the 1 meg resistor tied across the jack itself. 68K resistor in series going to the 12AX7, and I'm going to use this coax to get the signal from here through the grommet to that tube. Alright, once again, Fender style connection on the input jack. Now I used a Switchcraft input jack. I would suggest that you do the same. These new cheaper ones on the market do not hold up, so why do it twice? Alright, we're all wired up here. You can see the coax hooked direct to the jack, and you may be saying, hey, where's that 68K resistor? Well, that's going to go on the other end of the coax. Let me show you that. Alright, what I'm going to do is take the 68K resistor. I'm going to put him in series with the center conductor of the coax, and then this end will go to the input of the 12AX7 pin 2. You can see that the ground has been cut on this side. We've got the ground on the other end of the coax going to the front panel. You don't want to ground it on both ends, or you could get some ground hum. Alright, so I J-hooked that into the center conductor, and then I'm going to put some heat shrink tube over this junction. Alright, there she is in the heat shrink tubing. I'll hook that to pin 2. And you may say, hey, why are you putting that resistor at the input of the tube rather than off of the input jack like Fender shows? Well, I found that having the resistor closer to the tube reduces noise. So you can do it either way you want. But that's just what I found works best. So the wiring is complete. I'm going to give it a careful inspection. Then we'll pop in the tubes. The last step will be to try our bias resistor and set the 30 milliamps of current through the 6L6. Well, here we go. Initial power up. You can see I have not installed the bias resistor. He's sitting outboard, and I've put a current meter in line. We have a variac, volume's all the way down, so I'm going to bring up the voltage slowly. I'm watching my current over here, which you can't see, but right there is about 50 volts. No smoke. Good thing. Alright, now let's just watch the current meter. As the 5Y3 warms up, you should start seeing the 6L6 pulling current. If you don't, you probably did something wrong. Oh, here it comes. Now remember, I'm looking for about 30 milliamps. The 1K resistor was a guess. I have yet to find a calculator online that tells you at this plate voltage use this resistor to set this type of current. So I pretty much do it by substitution until I get the current that I'm after. Alright, so now I'm up to about 75 volts. You can see our current is already going over 20 milliamps. So that tells me if I go to the full 100, we're going to go over the 30. Okay, so I'm going to get close to 100. Look at there. See, I'm already going over 30 mils. So that resistor needs to be increased to limit the current further. Well, 1K didn't work, so now I've got 2K. I put another one in series. We'll bring our voltage up. See what we get for current. So I'm at 75 volts applied right now. Here comes the current meter. Now remember, we were well over 20 milliamps at this point with the 1K, so now I'm going to take her up full bore. $26. Alright, now let's go to line. So now the variac is totally out of the equation. Looks like 27.5. So I need to be somewhere around, say, 1800 ohms if we really want to hit the 30 mils, but 27.5 isn't bad. So I'm going to see what I can find in the 1800 to 2K range in my resistor pile. Alright, I found a 1.8K resistor. Crank him up here and see what we get. Alright, there's full voltage. Alright, there's our 30 milliamps. So I'll update the schematic to a 1.8K resistor rather than the 1K. Well, there's the amp powered up with a 1.8K resistor on the cathode, pulling our 30 mils. You can see we've got about a 52 volt drop across that resistor. So I ended up changing out the cathode cap to a 100 volt cap rather than the little 63 volt one that's on the schematic, so I'll also change that. Another thing I wanted to point out is that this time I am still running the filaments the way that they were originally configured in this piece of equipment. So one side is actually grounded to the chassis, okay? If I find that we have excessive hum, I'll raise that and do the old Fender floating balancing trick with 100 ohm resistors, but right now let's see if we can get a signal through this thing. I've got the amp hooked up with my audio generator as an input. Got a dummy load here, and as I suspected, I'm getting some filament hum. If you look at the scope, you can see it. So I'm going to have to go ahead and rewire the filament circuit with the balancing resistors, and we'll try it again. Alright, so here's a plan. Currently this side of the filament wire goes to ground. I need to raise that off ground so I can add the balancing resistors. So over here is a simple junction of these two red wires. So I'm going to raise those, heat shrink them together, move that lead over, add the resistors. Well, I corrected the wiring, put in the balancing resistors. Let's see now if we have a good sine wave. You saw that distortion before. Now look at her. We're good to go. That's what happens when you try to take a shortcut. We got D-Lab. Here we go. I'm going to run a signal through the amp. We'll just take a look at the output on a scope through a dummy load at this point. And after that I'll hook up a guitar, right? And you guys just love my playing. Alright, so we're going to bring up the volume here. I'm coming into it with about a 1 kilohertz tone. My master's all the way up. So there's my treble. Go up in frequency. Right? So she's working. Now, master all the way up, volume all the way up. What do we get? Just a little bit of clipping there, looks good. So now if I crank back my master, bring up the volume, now I can play with my preamp gain level, right? So the master is working great. Next thing we need to do is hook up a guitar and see what she sounds like. Alright, it's live test time. I have the amp hooked up into a pair of Celestion 12s, and we're going to monitor it on the scope, because a lot of you guys said, hey, it'd be cool to see what a guitar looks like as well as hear it. So here it is. But first off, we're going to just check our noise level. Now the amp is on. There's absolutely no hum, no power supply hum. Master's all the way up. Here's my volume. Here's my treble. So she is dead nuts quiet. Alright? Now comes some of my fine playing. Bring up the volume a little bit. Here you go. Alright, bring up our treble. Killer bass. Bring up the bass. Volume. So you get the picture. She is really working well, better than what I expected. Next, I need to get somebody over here that can play. Well, here is the updates to the schematic and the layout. So let me post those. So the major changes were the addition of the balancing resistors on the filament circuit. I moved the high voltage feed to the plate circuit direct to pin 8 of the 5Y3. Now the screens go through the 1K resistor and then they go up, feed the voltage divider for the 12AX7, more in the line of what Fender did. I also updated the bias resistor off the cathode of the 6L6 to the 1.8K 5 watt and updated the value of the 100 microfarad cap. Now that's 100 volt because we got well over 50 sitting on it. If you'd like a copy of this schematic and the layout, I'd be glad to send you a JPEG image of each. Just send me an email. Well, this amp turned out better than what I thought. I cannot believe how quiet it is. So in part 4, I'm going to get somebody over here that knows what he's doing and play that amp and make any recommendations that he sees fit.